Hello guys, welcome to Code Studio. This is our fourth session in end-to-end machine learning project playlist where we will start actual coding for our requirement. Okay, so basically, we will start writing a Python code to train the model and expose this as a REST API so that anytime in future also the same model can be retrained. And also, we will write a Python code to predict the results for a new data file, and it also must be exposed as a REST API. Okay. In previous session, we discussed how to select and create a best model using a Jupyter notebook. Okay, so we directly can use same model by saving that model as a pickle file and expose that as a REST API for a prediction only. However, in our requirement, we are assuming that client also want a REST API to retrain the model using a new set of training data files. It means they do not want one-time trained model, okay, like a pickle file. They want a model should be able to retrain whenever a new set of training files are given. Okay, so you can check the previous session by clicking I button. So basically here is the expectation from client that once his model is built, okay, they want a REST API to train the model using a training batch dataset whenever they want. And also they want a REST API to predict the result from, the prediction batch set. I mean, once they want, the REST API should be able to predict the results for a multiple files at once. Okay. So these are the high level steps of development. Okay. So first step would be creating a Flask project. So in this example, we are going to use a Flask web application framework. And the second step will be, writing a Python code files to train the model from a training sets. Okay. And expose this as a REST API. I mean, we will write some Python codes to read the training data, do the data pre-processing activities, do the quality checks and all, and store it in the database. Create a model, save those models into a designated directories. All these activities will be done by using those Python files. Okay, so we will write those Python code. Similarly, third step, okay, there also we will write few Python codes to for a prediction the results for a given new files. Okay, using a trained model and store those results in a designated location. Okay, and this also must be exposed as a REST API. So basically, these are the high level steps we are going to perform. Okay. Now we will try to understand each one of these steps in depth. Okay. So first step is the create a Flask project. Okay. In this step, basically we are going to create a Flask project folder structure where the code files can be stored. Okay. Then we will create a virtual environment, so which is used to initialize the supportive or dependent library versions. Okay. So once we create the virtual environment, we will install the required libraries using a requirement.txt file. And finally, we create a one Flask application, which will be our first code file, okay, which is used to run our entire Flask application. So once we are done with the Flask project setup, we will try to run and test the app. Okay. To complete this project, basically we are going to use two tools. Okay, the first tool would be your PyCharm. Okay, that is the IDE to develop our project. Okay, so we will write all our Python code using a PyCharm tool. Okay, and the second tool would be Postman, which is used to test the REST APIs. Okay, now let's start the coding. So guys, this is the URL to download the PyCharm IDE. Okay, so once you download, you will see the icon like this. So let me go and open the PyCharm IDE tool. Okay, now to create a Flask project, you have to go to navigation like file, new project, and give you the project name. Okay. So once the project gets created, the folder structure will be looks like this. Okay, this folder is for virtual environment, which has already been created. Okay, so these files will get created when virtual environment creates. Now we will create a few more folders. So this is the way. So first folder would be static, and second folder would be template. Okay, so the use of template is to create and to hold the HTML files like index and all the HTML pages, whereas the static file will be used to store the JavaScripts, images, and style sheets, CSS files and all. These two folders I'll use when we start developing the UI component. Okay, as of now we just creating the folder structure of of our Flask project. Okay, now let me import the libraries whatever required for our machine learning model. Okay, for that I have to create a file called a requirement.txt file. So to create it, the requirement.txt file, navigation will be select the project, new, and the file. Okay, type requirements.txt. This file is used to store all the required libraries and its versions. Okay, basically what happens, once we initialize the project, or when we deploy a project to the next server, so automatically it will install all those required libraries which are there in the requirements.txt file. Okay, in some the cloud servers we may need to manually install by running this requirements.txt file, and in some cloud servers it gets triggered automatically, and it will import all those libraries. So I'll add all the required libraries in the requirement.txt. So these are the minimal required libraries for our application. So Flask, this is for a Flask library or a Flask application framework. Okay, this is for a cross origin resources, and this is for matplotlib, this is for numpy, pandas, scikit-learn, this is for elbow plot. Okay, we will see later once we start developing the code for these. Okay, this is for the XGBoost, the algorithm. This one Flask monitor dashboard, this is for Flask app monitor dashboard. Okay, we will also see this one once we start using the dashboard of the Flask application. Okay, these are the two libraries on which the Flask is dependent. Okay, the remaining three are for the security reason. Okay, till now I just added these libraries in the requirement.txt file, but these are not yet installed in my machine. I mean, in my for this particular project, these libraries did not yet get installed. Okay, so now what I'll do, I'll write a first my Python code file. Okay, we call it as a Flask application. Okay, that will be the main file which will get triggered when application, okay, Flask application runs. And okay, so let me create that. So go to this is a Python. I'll give the a module name or my file name as a main.py. Okay, now you can see, right, when I created my first Python code file. Okay, now it asks for all these libraries to get installed, because the PyCharm automatically detects this requirement.txt, and it tried to validate it whether these libraries gets installed or not. So currently these are not yet installed, so that's why it's giving in a message like this. Okay, it has to be installed. So either you can click on ignore requirements, or you can click on the install requirement. So for my project I need all these libraries, right? So what I'll do, I'll install all this. So by clicking on this, okay, these are all the selected. So now you can see these packages are getting installed, so it will take some time. So I'll pause this video for now, and once all libraries gets installed, I'll come back. Okay, so guys, all libraries seems to be installed. Okay, so let me write some piece of code inside this main.py. Okay, so these are the few required libraries I'm importing, and then after I'm initializing this object Flask object. Okay, this is my route. Okay, and it is nothing but my domain slash this path. It's a training. Okay, so when you hit that URL, domain slash training URL. Okay, so basically it will call this method, okay, function, I would say. So inside that function I have defined this. Okay, like try and cache, the accept cache I handled. And to activate run this application, basically this piece of code will get executed. Okay, this is my basic structure of Flask application. So now let me run this application. So select right click and click on run button. Now you can see the URL been generated, right? So it means my the application is up and running now on this particular URL. So now let me test this URL. Okay, so to test the URL, okay, so basically this URL slash training, okay, this will be my the URL for a REST API. I'll use the Postman the tool to to test this REST API. So let me copy this URL, open the Postman. So that is my post request, right? So post method I'll have to use. I'll just let me copy this as well. Okay, so let us run. See, now you can see that you have received the response. Okay, It seems our our the Flask application is working fine. Okay, and one more thing, like usually we do not use this piece of code. Okay, instead of that, okay, we will use this. So let me comment this. Let me run this. Okay, now instead of, let me retest this. So instead of this IP, so I'll use 00s. Okay, see, you receive the response as well. So guys, this is another basic way of building the Flask project. Okay, if you wanted to know more about the Flask, the framework, you can go to the this URL basically. Okay, you'll get lots of the tutorial and the examples of Flask framework. Okay, so as we are already completed the Flask project, right? Now we will start to write Python code to train the model and predict the results. For that we'll have to follow for the following steps, like first of all we will create a few additional folder structures inside the Flask project. Okay, then after we'll write a code files to train the model, and also write a code file to predict the results, and finally we will run our application and test the results. Okay, so this is my Flask project. So let me create a few more additional folders. First one is data, to store the data files, like the training sets and the the prediction sets. Apps folder, to store all the code files. Now we will create one more folder called logs, to store the logs. Okay, so these are the three folders I have created, and inside these parent folders I'll also create some the child folders. Each folder will have their own meaning, so let me create those folders quickly. So these are the two child folders I have created inside the logs. Okay, so prediction log will store the log files of the predictions. Okay, the training logs will store the log files generated while training the model. Okay, similarly in data folder also I have created these many child folders. Okay, so let me explain the use of these folders. So we'll start from the training data. Okay, training underscore data will be used to store the training files. Okay, training dataset files, which will give shared by the client. Okay, once we receive the files in a training underscore data folder, okay, the training files, those files has to be validated. Okay, so we need to check the quality about those files, like number of columns and its data types and all. Okay, so once if there is any issue, okay, so those rejected files should get rejected and loaded into this folder. Okay, and if everything is okay at the validation level, okay, then all training set files should get stored into the database. Okay, and generate one common file. Okay, common CSV file that will be loaded in this folder called training data validations. Okay, and these processed files, okay, which the training set which is already been processed will get moved to the the processed folder. Okay, and this archive folder will be used to archive the the already processed files, like whichever file is there in these three folders. Okay, whenever you run a new next run, okay, these already pre-processed or rejected files should get archived and and stored into this archive folder. Okay, similarly we have created a folder structure for prediction files also, like in a data, archive, process, rejects, results, validations. So this results is the additional folder will have in the prediction data set. Once the data model predicted the results will be stored in this particular location. Okay, now let me open the apps folder. So inside this I have created these many child folders, so I'll start by one. Okay, so the first folder is core. Okay, this folder is used to store the code files which are generic. I mean those code or the files can be shared or used by other code files. Okay, like the log files, logger files. Okay, and the configuration file. Okay, where we can store all the the hard coded or constant values. Okay, database folder, it is used to store the database operations. Okay, we will write a the code which will have all the database operations inside that. The ingestion, this folder will have hold the code of the data ingestion, like the loading of training data sets and then validating of training data set before it is before it's processed. Once quality the quality about the training set is validated, okay, the next step would be the pre-processing activity, right? So those code will be stored in the pre-process folder. Okay, training folder will hold the code which is used to train the model. Okay, and from this code file, it will call the all these code files, like these ingestion, the pre-processing, all these. Okay, this tuning folder will be used to hold the clustering and model optimization code which is used to tune the model. Okay, once models are selected, I mean the best model is selected, then those models will get saved into this model folder, and this prediction folder is used to create a code to process the prediction files. Okay, now let us start to write a code for training the model. Okay, so first code file I'm going to write, that is a configuration file. Okay, so this is a Python file. Okay, let me create a module called config. Okay, which is used to store the configuration class. Okay, and here is the code. And in this development, we will also focus on the coding standards, okay, which is must in real-time industry. Okay, so this is the code file or class for the configuration. Okay, so this is my class name config. Okay, and this is my header comment for this particular class, where I had given the what is the file, the module name, the version, author, and the creation date. Similarly, the change history is who is the developer, when, and version, and what is the changes. Okay, and the small description about the class file. It is a best practice to maintain the header comments, okay, and the individual line comments, as well as the block level comments. Okay, so this is one of the comments. Okay, this is called block level comments. For each method, okay, we have to add the block level comments as well. Okay, basically in block level comments, these are the few the attributes we need to update. Okay, these coding standards we follow, okay, only to maintain the readability of the code. Okay, so that in future, if any other developer comes and works on the same code, he will easily understand with this go the code the comments and all. Okay, so let me go through the individual methods. Okay, so basically this is my a class. Okay, the class for configuration in instance attributes. Okay, this is my constructor. Okay, which where I'm storing a construct variables like the training data path. These are I just hard coded. The database name should be training for a training database. Similarly for prediction database, it should be prediction. And what is the data path for training files? So this is the data and the training data, right? And for prediction data files, this will be the path. Similarly, we have a method called getRunID. Okay. So this method basically used to get the a unique value along with the dates. Okay. This method will be used while generating a log files. For every run, okay, this method will give a unique run ID. Okay, and based on the run ID, we can find the log file and we can trace all the log entries. Okay. Similarly, I'll create few more modules inside the core folder. Okay. So these are the additional modules. Okay. So let me open the logger and I'll explain you. So this is the logger class. Okay, so class to generate the log files. Using the single the logger class, we are going to generate the log files for training as well as the prediction. Okay, so for that purpose, this is the differentiator. Okay, so I mean, if let's suppose if we are generating or running a code for training the model. Okay, in that case, the logs which will get generated, that will be stored in training logs. Okay, and when you run the code for a prediction, those logs will get generated in prediction. So for that purpose, I written this piece of code. Okay, and these two methods, this is for normal information, and if something went wrong inside the code, okay, if some error exception occurs, then the exception method will be used to store the exception logs. Okay, now the file operation. So here is the class. So class for file operations. Let us understand what are the methods it has. Okay, the file operation has method called save model. Okay, so method to save the model file. Once the training model is built, the model has to be saved, right? So for that purpose, this method will be used. Okay, to save the model. Okay, so this is a piece of code. Similarly, load the model. So while predicting your data set, right, so you have to load the saved model. For that purpose, you have to use the method called load model. Okay, this is a custom method we have created. We have a final method called correct model. Okay, this method to find the best model. So basically, in our exercise, we are going to use the two models. Okay, random forest and XGBoost, and also on top of that, we'll also apply the clustering. It means there is a chance of the multiple models will get saved into our the system. Okay, out of those multiple models, we have to find the best model. Okay, for that purpose, we have created this method. Guys, maybe I'm quite fast, but don't worry. I'll upload all these code files into my GitHub repository. Okay, and that URL will be updated into the description box. Okay, so you can get this code from the GitHub repository. Now let me quickly create the other code files also. Now let us see the database code files. Okay, so yeah, schema train and schema predict. Okay, before explaining this, let us see the data file. So this is my data file, okay, which it is there in the training data folder. Okay, let me open this. Okay, so these are my data. Okay, so the last column is left, that is my target column. Okay, and these are my the input features, and the last one, that is the left column, is my target column, that is my dependent variable. Okay, now let us open this schema underscore train.json. This is the file, okay, where I just updated all the columns, okay, of my training set. Number of column, that is 10. Okay, similarly we have a one more file called schema underscore predict. Okay, there we'll have a similar structure except the target column, because in prediction file, okay, the output variable will not be there, that is has to be found out by our trained model, right? Okay, basically why we have created this, so these are we have created to create a database tables with these columns. Okay, also to validate our training data set, okay, before sending it to the model to train, like whether the training set which is given by the client are following the same data structure or not, or same number of columns or not. Okay, for that validation also these schema files will be used. Okay, now let me open the database operation file. Okay, so this is basically the class to handle the database operations. Okay, so here is the first method called database connection to create a database connection. Okay, basically here we are using a SQLite, okay, a database. Okay, and this method will use to initiate or create a connection with the SQLite. Okay, this method, the create table, this method is used to create the database table. Okay, so in our exercise we are going to create two tables. Okay, that is, one is for a training data set and another one is for a prediction data set. Okay, so this is the code, and this method, okay, will be used to insert the data into table. Okay, and the export CSV, basically method to select the data from table and export into CSV. Okay, so in generally what will happen, so the client will share a multiple training set files. Okay, I mean the batch files. Okay, once you reprocess those files, okay, all those the processed data or validated data, okay, will be stored in a database and export as a one single file, okay, as input.csv, and this CSV file will be treated as a one main data set to train the R model, or similarly for the main input file for a prediction also. Okay, now let me open the ingestion folder. So load and validate, so basically as I mentioned, like the load and validate, it is used to read the data set, okay, and do the basic validation about the data set, like number of columns, the name of the columns and all. Okay, let us understand the methods of this particular module. Okay, so values from schema, so this method is used to read the schema file, like I have seen the shown you, right, these the schema files. So this method will be used to read those data. And validate column length, this method is used to validate number of columns in the CSV. I mean in training set, okay, so number of columns, how many, so there'll be 10, right, and in prediction there will be a 9. So basically this method will be used to calculate or count the number of columns available in the set, and if anything wrong in that, okay, those files will get rejected and stored into the reject folder. Okay, so validate missing values, method to validate if any column in the CSV file has all values are missing. If there is any such column, fine, then that file also will get rejected and then loaded into the reject folder. Okay, replace missing values, so method to replace missing values in a columns with a null. Okay, any missing values are there in the file, those the values will get converted and updated with the null. Okay, archive old files, basically this method to use to archive the old processed files or rejected files. Okay, this is a piece of code written for that. Move processed file, once this file is processed, okay, then this file should get moved to the process data folder. So for that purpose we have created this method. Okay, validate train set, so basically this is the method, okay, which will get triggered first when you start train the model. Okay, and inside this method it will basically call the all the these methods. Okay, Like, first of all, it will archive all the old files. Then it will get the column name and the number of columns from the values from schema method. Then it will try to validate the column length, validate the missing values, replacing the missing values. Okay. Once all these activities are performed, okay, then it will perform the DB operation, like it will create a table, okay, a name called training underscore raw underscore data underscore t, okay, and the database would be training. Then after it will insert all the training set data into this table, okay, then it will export a common CSV file by exporting the data from this table, okay. And also once all these activities are done, the processed file, that is this, okay, should get moved to the processed one. So for that I'll call this method, okay. Similarly, for a validate predict set also, okay, we had written a code like this, okay, okay, okay. So now let us understand the code execution sequence, okay, from our main file, okay. This is the main. So I made few changes in this file, okay. This is the the route for my training model, okay. I initialize the configuration class, okay, to get the run ID and the data file folder. And I initialize the train model class, okay, and I'm calling the method called training model, okay. So basically this is my first method, okay, which is used to train the model, okay. So let us go through its code, okay. And before that, and check the response also, like I just did some minor change, along with the training successful this message, I'm also popping up the run ID, okay. Now let us check the train model, okay. Basically this is the method of model called train model, and the class will be train model, okay, right. So now we'll see the sequence of the code or methods inside this particular method, okay. Train model, basically this method is used to train the model, okay. So first two lines to generate the log files, okay, and the third line, this is for load validation and transformation, okay. This is one of the class, okay, load validate, and this is one of the method, that is validate and validate the training set. So basically in this method what will happen, it will try to validate the training set files, these batch files, whether the number of columns are given correctly or not as per our schema file, okay, or then the name of the columns are correct or not, any missing values are there. So all these validations will be done by this method, and then if anything wrong in that file, okay, then those rejected files will get moved into the rejected folder, okay. Now let us see the code of this particular method, okay. This is a method of module called load and load underscore validate, okay. So basically this method is used to validate and transform the data. Inside this method we have called so many child methods, like the archive old files. This method will be used to archive the existing old processed files, okay. Similarly, this is another method, values from schema. Basically this method is used to return the number of columns and number of the name of the column present in the schema file, that is called the schema underscore train, okay. And based on this number of columns, it will also validate the training set, whether it has all the the number of columns what we have in the schema train, okay. And then after, it will also check the another validation if any column has any null values, okay. And if any the missing values are there, it should get updated with the null, okay. So these are the validation, the transformation activities we are performing at this stage. Once everything seems to be good, okay, then those the validated files, okay, will be stored into the database, okay, in form of table rows and columns, okay. So for that, this is the method create table. The training will be your database name, this will be your table, okay. Once table gets created, it will insert the training set data into the table, okay. And finally export CSV, and finally it will generate a one common CSV file, which will act as the input data set for training the model. And the move processed files, this method is used to move the processed files from the training directory to process directory, okay. So this was all about the activities will be performed at the validation, okay, validate and train set method. Okay, now once we're done with the load validation transformation, then the next step would be we have to pre-process the data. For that we have created another class called preprocess and the method called preprocess train set, okay. So from this method, it will do all the pre-processing data pre-processing activities, and finally it will x and y variable, okay. That is my features or independent features, and the dependent variable or a label. So let us see now the code of this method. So basically this is the method. Okay, this is the module. Okay, inside this we have a method called preprocess train set. Basically it does following the activities, like it's getting the data from the data set. Okay, then it is dropping the column called employee id, then it's handling the categorical features, and then finally it's dropping the output categorical feature because it's already been converted, right? So now it's dropping the salary feature. No, and also it is checking the missing values. Okay, if there is any missing values, then it will perform the impute missing values, and finally split the data into x and y variables. Okay, now let us quickly go through the individual these methods. Okay, so here is the first method to read the data file, and this is for to drop the columns from the data set. Is null method, so it is used to check the null values. Impute missing values, if there is any missing values, then using this method we can fill. So for this basically for impute, okay, we are going to use the knn imputer in this case. Okay, similarly for to handle the categorical features, we have a method called feature encoding. So using get dummies, we are converting that. Now we are splitting the data into x and y variables. This method for a prediction, so we will see what it is when we start work on the prediction methods. Okay, so that's all. Now let's go back to the train model class. So once the pre-processing activity is completed, okay, and split the x and y variables, okay, now we will create a data underscore columns, okay, dictionary variable, and store it into the columns.json file to store the all the the latest columns, okay, available after pre-processing activities. I mean, once we apply the encoding feature, right, the categorical the encoding features, then number of columns will get increased, right? So for that purpose only, the new number of columns along with the old number of columns will be stored in this or the columns.json file. Now next up is creation of clustering. Okay. Basically, this elbow underscore plot, this is a custom method which is used to the cluster the data set and return the number of clusters. This will basically help us to cluster the data set or group the data set, and based on each group, okay, we can apply different algorithm. Okay, so let me go through the elbow plot. So this is the method of of cluster class. Method to save the plot to decide the optimum number of clusters to the file. Okay, so using to clustering for clustering, basically I'm using a k-mean cluster algorithm. Okay, this is the code for that. Again, now go back. So now we have got the number of clusters. Now this is piece of the code to, to divide or cluster the data based on the number of clusters. Okay, so this method is used to create the the data into clusters. So let us go and see what it is. So this is the method. So method to create a cluster. This is a piece of code. So using k-mean clustering, okay, I'm splitting the data set into the clusters. Okay, I can go back. Now we are done with the clustering. Now what I'll try, parsing all clusters and look for the best ML algorithm to fit the individual clusters. Okay, so basically I'm splitting the cluster data, okay, into features and labels. And for each cluster, we are also splitting the data into training and test set. Okay, using this. Okay, then after those training and test sets will be passed to this method called get best model. Okay, where I'll use two algorithms. Okay, random forest and XGBoost, and we'll try to see which model gives the best results okay, based on your training and test set of particular cluster. Okay, so let us see. So this is the method of the model tuner class. Okay, now in first case I'm trying to get the score of XGBoost model. Okay, then after the next iteration I'm doing for a random forest, and based on the scores of these two models, okay, I'm comparing and which model gives the best results, I'm returning that model. Okay, and so that based on that particular model with respect to the cluster will be saved. So let us go back to the main model, that is a train model. Okay, so now we are done with this. So for each cluster there will be a one best model. Okay, and for each cluster that model will be saved. Okay, so like this, for each cluster the model will get trained and saved. So that's it, guys. I hope you understood the sequence of coding to train the model. Okay, now go back to the main file. Okay, run this application and see and test the results using a postman. Okay, so once you click on submit button, okay, it will send the request. Okay, it takes some time, okay, because the data set size is very high. Once it is completed, it will give you the the response with the run ID. So based on the run ID we can find the log file and we'll see the entries and if there is an error. Okay, so guys, this has completed now. Okay, my training model. Okay, and the response is like this. Okay, the training successful and its run ID is this. Okay, so let us go to the PyCharm and let us see the log file. Okay, so here is my log folder. Inside the training logs I can see the log, okay, with the same run ID. Okay, let us open this. Okay, these are the log entries for this. Okay, this is my run ID. Okay, let us see all these log entries. Okay, it seems there is no issue. And see the number of clusters for given data sets. These are the three. It means my data set got clusterized into three sets. Okay, for a first data set, okay, these are the scores of the results. I think this is for random forest only. So as per these, okay, the XGBoost gives the best results with these parameters. Okay, for a first cluster. Similarly for a second cluster, okay, here also the XGBoost is giving the good accuracy 98, whereas the random forest is giving 96 percentile. Okay, for this particular parameters. Similarly, we have a third cluster, so third model. Here also the XGBoost with different parameters. Okay, so it means, okay, so there will be three models. Okay, should get saved in our model folder. So let us see. Yeah, you can see, right? Now these are the three for each cluster. Okay, denoted by 0, 1, 2, 3. Okay, the model is same but the parameters will be different. Okay, and the key main clustering, this model is stored to find the correct cluster name. Okay, cluster number. And also you can see the columns.json file got created. Okay, with some additional columns like salary, medium, salary, low. Okay, these are the categorical encoded features. Okay, and also the training.db, this is the database got created to store the training set data. Okay, so that's all, guys. So I hope you understood like how to write a code to train the model and expose this as a REST API. Now let us write the code to predict the results using our trained models. Okay, so let me create a new route. So this is a here is the route. Okay, batch prediction. Okay, this will be the method for that. Okay, once you run that particular URL slash, I mean the domain slash batch predictions, this method will get invoked. Okay, a method to call the batch prediction route. So here is the code, the similar logic what we had written in for a training model. Okay, so there's a prediction data file path. Okay, this is my predict model object. Okay, where I'm passing run ID and data path, and this is the method, okay, which is used to predict the results. Okay, so let us see what is the code written inside that. So is the new file. Okay, I have uploaded inside this prediction folder. Okay, predict underscore model. So this is the method inside that class. Okay, so batch predict from model. Okay, here also the similar activities, the most of the things will be similar at what we have seen in the training model code. So like this one. Okay, so validate and validate the predict set. it will do the similar the data quality validations what we have seen it for a training data set. Okay, once the validation is done, okay, all the invalid files will get rejected and loaded into the rejected the prediction data rejects folder. Okay, and if there are any valid files, okay, those will be loaded into the database. Okay, and one common file will get generated which is used for to predict the results. So let us go and see the code sequence. Okay, so archive old files, get in the column name, number of columns on the schema method, validate the column length, validate the missing values, replace the missing values, create table, insert data, export CSV. Okay, the similar what we have seen in the training data set. Okay, go back. Now the next step is another a pre-process predict set method. Okay, which is used to perform the pre-process activities. Okay, let us see what are the code is there inside this method. Okay, so first one is getting the data from the data set. Then after handling the encoding categorical features, dropping the categorical feature, handling the missing values, then after finally prepare the final predict set. This is the method actually. This method is used to build the final predict set by adding additional encoded columns with the value as 0. Okay, let's suppose in a new set of data files, okay, which has to be predicted, if that file does not have a the categorical feature values. Okay, but those values or the columns are there in the training set. Okay, or in a trained model. In that case, if the the prediction set doesn't have same feature, then the encoded feature, then it will not give a good result, so it will throw an error. So that's why to handle that, we are creating those feature with the 0 value. Okay, how we are checking whether those columns are exist in the training set or not. So basically using this column underscore JSON, okay, which got created while training the model. Okay, this will hold the all the latest the final version of columns of the training model. So basically, this method will try to compare, the prediction set columns with the columns underscore dot JSON file, and if there is any missing column, then it will create that feature with the 0 value. Okay. Once the pre-processing activity is performed, okay, now second activity will be loading the saved model. Okay. In training set, we have created or saved the multiple models by clustering the data set, right? So similarly here also we have to find out the cluster number based on our the predicted input values. To find the cluster number, I have to use a k-mean clustering algorithm. Okay, so which is also there in our model folder. Okay, so once I get the cluster number for this particular input, okay, variable. Okay, so based on that cluster number, it will try to load that saved model. Okay, so first of all it will try to get the that particular model, and then after it will load that model, and using this predict method, okay, it will try to get the prediction values or results. Okay, and these results will be stored into the prediction.csv file inside this results prediction results. Okay, and this prediction file will have two columns, employee ID and its prediction value. Okay, now we will upload one sample prediction file and we'll try to run and check its predictions. Okay, I have a sample data file. Okay, for a prediction I have uploaded in the prediction underscore dataset. Okay, now let us go and try to run and test the batch prediction results. Okay, so here is the code. Okay, this is the URL post method. Let me click on this, send. Okay, this got created. Let us see the log file. Okay, this is the latest file. Okay, so there is no error. Now let us see the results. So this is my results. Okay, so this is my employee ID, and this will be my output in form of 1 or 0. Okay, so it seems like the data set is split into two clusters. Okay, and also we'll see the database. Okay, so now the prediction database also got created. So that's all, guys. So I hope you understood how to write a code for prediction. I'll upload all these code files into the GitHub repository, and I'll update the URL in the description box. Okay. So that's all for now, guys. So if you like my video, please click on like button and subscribe my channel. Thank you so much.